Hello and welcome to the Unit 3 Section 1 video on lines and angles. We're going to start off by identifying types of lines and planes, and we have two main types, and those are parallel and perpendicular. We've already talked about those two, but we're also going to throw in skew lines as well. So we're going to learn about the terminology here up front. Parallel lines are two lines in a plane that never touch. Okay? Or you can also say they never cross. Okay? So they never touch or they never cross. The symbol, two vertical lines, mean that is parallel to. Okay? That's our shorthand for is parallel to. Arrows are used to show parallelism in a diagram. So you can see one little tick arrow here and one little tick arrow here between the two lines. This indicates that these two lines are parallel. So let's move on to perpendicular lines. Perpendicular lines are lines that intersect at a right angle, which means that where they intersect, it's going to form a 90-degree angle. The up the side down T symbol means it's perpendicular to, so that's our shorthand for perpendicular. A square is used to show lines are perpendicular in a diagram. And we've seen this before. The square means that the lines are perpendicular. It also indicates a 90-degree angle. So it does both of those things for us. Skew lines are non-coplanar lines that are not parallel. And they are also lines that do not intersect. So you have to think about this a little bit more three-dimensionally. In a three-dimensional space, you may have one line going up and down and another line going side to side, and they're next to each other, so they never cross, but they also are not parallel. Parallel planes are planes that do not intersect. So think about one sheet of paper being held over another sheet of paper. Those two planes are parallel and they never intersect. So let's take a look at an example. We're going to use the figure to identify the following. First, we're going to identify two pairs of parallel lines. Well, we've got AB and EF. Those are indicated for us. So we're going to do AB is parallel to EF. Go ahead and draw that correctly. Okay. We also have two other lines that are indicated for us, and that is GE and HF. Now there are others. These are not the only two, but these are the two that are indicated for us. So those were the easiest to pick out as an example. Now we're going to do two pairs of perpendicular lines. Again, let's look for the ones that are indicated for us. Well, we have EG and we have HG right here. So EG and HG. And then we also have HD is one and DB is one. But let's go to the one that's indicated. How about AB and AE? And of course there are others. We did just point out another one. All right, now let's do two pairs of skew lines. So we've got EG, which is going up and down this way, and AB, which is going side to side this way. Never cross, but also are not parallel. EG and AB. And there's no symbol for skew, so we just have to use the word and here. And AB. And then we also have FH, which is here, and CD, which is down here. FH and CD. And now, one pair of parallel planes. Well, we've got plane EGH, which is this front face. And we also have the back face, which is parallel to it. Plane ABC, ABD, BDC. You can name it however you want. Let's name it plane DBA. All right, moving on to the next example. We're going to use this figure to identify the following. Again, two pairs of parallel lines. So let's see, we've got AB, which is here, and VW. And we've got DE and YZ. Two pairs of perpendicular lines. We've got DY and YX right here on the bottom. And then BW and BC. BW here, BC here. All right, now two pairs of skew lines. Let's try CD and WX. Again, there's no symbol for skew, so you have to just use the word and here. And then AE and XY, which is down here. All right, and a pair of parallel planes. Well, here we only have one option. That's the front face and the back face. So we've got plane ABC, which is the back face. Again, you can use any three of these 5 letters to name it. And then plane VWX. So plane ABC and plane VWX. All right, in example 3, we're going to be using the figure to finish the statement. So plane FGE, which is this front face, is parallel to which plane? Well, it would be the back face. So IJH. Now, we need 2 lines that are skewed to JG, which is this one right here. So we have FE and IH. All right, FE is parallel to which line? That would be IH. GE is parallel to which plane? So GE is here, so it will be parallel to the plane that's on the back face, IJH or IHJ. Again, you can name that plane however you like, just as long as you use the 3 points. All right, which line contains point J and is parallel to FGE? So FGE is here and contains point J, so we could use either IJ or HJ. Let's write IJ because it has to contain the point J. And then for example 4, we're going to use the figure to identify the following. Pair of parallel segments, all right? So they've only asked for one. So how about KN and LM? You could also do KN and PS. You could also do KN and QR. And then you could do any of these sides that are going up and down. So let's just choose KN and PS. A pair of skew segments. Well, we just pick one off of this side and one off of this side that are going in opposite directions. So how about LM, which is here, and we do RS, which is, well, we could do one down here as well. So how about LM and RS? A pair of perpendicular segments. Well, the easiest place to pick those out are right here where we have the box, so MR and RS. And a pair of parallel planes, KPS, which is this back side, and LQR, which is this front side. So plane KPS and plane LQR. All right, now let's talk about angles that are formed by a transversal. A line that intersects two or more lines in a plane at different points is called a transversal. And we're going to use this figure as our reference as we talk about the different types. When a transversal T intersects lines L and M, it forms 8 angles. And you can see those labeled in that diagram. Several of the angles in the pairs of angles are given special names. So, corresponding angles lie on the same side of the transversal and on the same side of the other two lines. So, basically, if we've got upper left, it goes with upper left. Upper right goes with upper right. Bottom left goes with bottom left. Bottom right goes with bottom right. So our examples here are angle 1 and angle 5. Angle 3 and angle 7. Angle 2 and angle 6. And angle 4 and angle 8. I like to say they are in the same slot. Upper left, upper right, and so on. Alternate interior angles are non-adjacent angles that lie on opposite sides of the transversal and between the other two lines. Basically, all it means is your interior angles are here in between the two lines. Exterior angles are going to be outside. So 1 and 2, 7, 8 are going to be exterior. Then alternate means we're going to cross. So 4 to 6, 3 to 5. You cross the transversal. Okay? So 4 and 6. And then 3 and 5. Alternate exterior angles lie on the opposite sides on the outside. So 1, cross over to 7, 2, cross over to 8. So 1 and 7, 2 and 8. Consecutive interior angles, and you're going to have to refer to your diagram in your notes as we move forward here. Consecutive interior angles lie on the same side of the transversal. So interior angles, we're again dealing with the ones on the inside. And because they are consecutive, instead of crossing over, we just go straight to the next one. So 4 to 5, 3 to 6. So angle 4 and angle 5, angle 3, and angle 6. And then the consecutive exterior angles behave the same way. You have 1 to 8. This time you're not crossing. And 2 to 7. So let's do a few quick examples with these. So example 5. We're going to use the figure to identify each of the following. First of all, which one's the transversal? Well, that one would be the one that cuts through the other two lines. So that would be line C. Two pairs of corresponding angles. So we could do 4 and 5. We can do 3 and 6. Two pairs of alternate interior angles. Well, there's only two of them, 1 and 6, 2 and 5. Again, we cross over for those. And then two pairs of alternate exterior angles. 3 cross over to 7, 4 cross over to 8. So 3 and 7, 4 cross over to 8. All right, in the next one, we have 3 lines going through each other, okay? Y is your transversal here when you talk about this set and this set. K is your transversal when you talk about these two sets. And then N is your transversal when you talk about the last two sets. So alternate interior angles. If we use line Y as your transversal, we're going to have 3 and 5. For corresponding angles, if we were to use line K for our transversal, we would have 9 and 2. Consecutive interior angles, if we were to use line N as our transversal, we would have 8 and 9. And for alternate exterior angles, let's use line, got ahead of myself, line K as our transversal here. And I'm just choosing one to use as our transversal. So angle 1, alternate exterior, that will take us to angle 10. All right, for the last example, we're going to use the figure to classify each pair of angles. So 14 and 10, here's 14, here's 10. Those would be corresponding angles. 3 and 5, we would have alternate interior angles. For 16 and 2, those would be alternate exterior. For 8 and 9, that would be consecutive interior, which you also may hear refer to as same side interior. Same side and consecutive mean the same thing. And then 11 and 6. 11's here, 6 is here. You've got consecutive exterior. All right, and that does it for this section of notes. So this is just a little bit of an introduction to parallel lines and also parallel planes and perpendicular lines. And we've started to pull some of the terminology when referring to angle pairs when we have angles formed by transversals. What we're going to do in the next section is, now that we know all this terminology, we're going to apply it. We're going to see, okay, now that we know how to identify all these angle pairs, what does this mean for us? And more specifically, what does this mean if you have a transversal cutting through a set of parallel lines? So that's coming up in the next section.